So this is just 1.2 on Classroom. And now we are recording. So here is our lesson 1.2 function notation. So hopefully everyone had an opportunity to grab that off our Google Classroom. This lesson is really quick. It's basically just us talking about our new notation and the way we're going to be writing things. So up until this point, if I gave you an equation, you always wrote it as like y equals 3x minus 4, or y equals 1/2 x plus 1 plus 5. We always had a y equals and then some sort of equation. But now that we're talking about functions, we're going to use what's called function notation. And that looks like this. F at x equals 3x minus 4, or g at x equals 1/2 x plus 1 plus 5. Basically what that's telling you is which one is our independent and which one is our dependent variable. How we read this is f at x. So it's saying what is f at a given x value. Same idea here. We have g at x. So g at x. What is g at a given x value? And the letter doesn't matter. Typically, it goes with whatever your let statements were. If we don't have let statements and we're not dealing with an application question, typically you'll see f at x, g at x, h at x. Those are typically the letters we use, but you can really use whatever letters you want. It's just letting us know what is our dependent variable and what is our independent variable. So the other thing that's useful about this notation is that I can sub in values for x, and I can nicely write it like this, like f at 2. And basically what that means is when x equals 2. So up until this point, we would say sub in x equals 2. But now we have this nice way to write it where I can just say f at 2 and then sub in 2 for x. So let's go through and do some examples because this is pretty straightforward once we get the hang of it. So for example 1, we have m at x is negative 2x squared plus 4. So the first thing we're being asked to find is m at 2. So what we're going to do is we just say m at 2 is equal to, and then we take our whole equation, but instead of writing an x, I'm just going to write 2. So just like we always would if I said sub in 2 for x, you're doing the exact same thing. The only thing that's different is our notation now. So now I'm just going to do BEDMAS. Again, you don't need to write out all of these steps. I just want to ensure that everybody knows where the numbers are coming from. So we'll have negative 8 plus 4, which will give me negative 4. So then we would have m at 2 is negative 4, and that would be our final answer. Okay, let's try another one. So in addition to just putting a number in the bracket for x, we can also apply other operations to our function. Oh, before we move on, Dimitri, do you have a question? You can unmute and talk, or you can type it in the chat, whatever you prefer. So in this question, the m here would basically be like me doing y equals 2x squared plus 4. It would basically be the same thing. We just do m at x. That's really the proper way to write it, to be honest. Y is just simplifying it, and we do that in grade 9 and 10 just to help you understand how to use the equation. But the m is just telling me that what is my y value at x, basically. So in other words, it's the same as y. It's just a different way of writing, like, for example, this one down here. It's just a different way of saying like sub in 2 for x without writing out that whole thing. Does that make a little bit more sense? Once we continue with it, I think you'll start to get the hang of it. It is a little bit weird when we first start just because it's new, but the more we practice with it, I think you'll start to get the hang of it. Okay, so let's try this one here. We have 2m at 1. So basically what that means is it means 2 times m at 1. So now in my equation, instead of writing an x, I'm just going to write a 1. So just like anytime we put a 2 or a number by anything, this means that this 2 is multiplied by this whole thing. That's what that means. So I find it easiest if I just write out the whole thing like this, and then I simplify it. So remember BEDMAS, that doesn't go away. So we keep that 1 on the outside of the brackets. We can just have it hang out there for a bit, and we're going to deal with the inside first. So first is our exponents. And if we haven't used it, it just hangs out until the next step. Then we're still simplifying our brackets. So we'll do the multiplication. And now we finish off simplifying the brackets. So we will get 2m at 1 is equal to 4. So it's a little confusing, but the more you start to practice and work with it, it does start to get easier, and it does make your notes a little nicer just because we don't have as much written down. It's a little more direct and to the point. Okay, let's try C over here. So for C, we have m at -2 minus 3. So m at -2 minus 3. So let's start out by writing m at -2. So instead of writing an x, we're going to put a -2. And then this whole thing minus 3. So now let's simplify that with BEDMAS. So -2 squared is just going to be 4. And then that will give me -8 plus 4 minus 3. And that will give me -4 minus 3, which will give me -7. So that means m at -2 minus 3 is equal to -7. So the more you start to practice with these, the easier it will get. Okay, are there any questions before we move on to example 2? All of our examples are going to be really similar. So if you're just feeling like I need to see more examples, we're going to just keep going. Okay, no one in the chat, so I'm assuming it's okay. Again, if you have questions, just stop me, I don't mind. Okay, so for example 2, we have f at x equals 2x minus 1, and g at x equals x plus 4 all squared minus 7. So the first thing we want to show is that g at 2 is greater than f at 2. So what we're going to do is we're going to just find g at 2 and f at 2. So again, all that means is that instead of writing an x, I'm just going to write a 2. So for g at 2, that will give me 2 plus 4 all squared minus 7. Now we're showing that that is greater than 2 times 2 minus 1. So again, all I did here is I rewrote G with a 2 here, and then I rewrote F, but instead of writing an X, I wrote a 2 here. Okay, and now I'm just going to simplify those, and we don't want to move things across that greater than sign. Just keep simplifying each on either side. So we're going to do the brackets first. So we'll have 6 squared minus 7 is greater than 4 minus 1. So over here we'll have 36 minus 7 and 4 minus 1. And 36 minus 7 is going to give us 29 is greater than 3, which is true. So that means we have done it correctly. And again, you don't need to show all of these intermediate steps. I just want to make sure everyone knows where everything's coming from. Okay, now let's try B. So we want to determine the value of f at 0 plus g at negative 2. So we have f at 0 plus g at negative 2. And that would be equal to f at 0. So we're just going to rewrite f, but instead of an x, we're just going to put a 0. So 2 times 0 plus 1, that's our first one, plus g at negative 2. So instead of writing an x, we're just going to write a negative 2. So we'll have negative 2 plus 4 all squared minus 7. And now let's just simplify those brackets. So 2 times 0 is just 0. So we'll have 1 plus negative 2 plus 4 is going to be 2 squared minus 7, like this. 1 plus 4 minus 7. And that will give me 1 minus 3. So we will get negative 2. So our final answer would be negative 2. If you're finding this really confusing and overwhelming, you're more than welcome to find this on its own, find this on its own, and then add them together. That's absolutely okay too. This is just the way you'll see it most commonly, so I want to make sure you're comfortable with it, even though it is a little bit more intense. Okay, so finally for C, we have G at 3b. So basically what I'm going to do is wherever I see an x in the G equation, I'm just going to write 3b instead. So instead of writing that x, I'm going to write 3b plus 4 all squared minus 7. Yeah, Tirth, you have a question? You can turn your mic off, or you can just type it if you'd prefer. F at x is 2x. Oh, I missed a minus. Sorry about that. Oh, my bad. I apologize. Oops. Thank you for letting me know. So I'm just fixing that in here. Sorry about that, you guys. So that should have been a negative 1, a negative 1, a negative 1, which would have made that negative 4. Sorry about that. Just dropped to negative. It's super easy to do. The same steps. I just totally made a little mistake there. Thank you for letting me know. Okay, so for C, all I've done is instead of writing x, I've just written 3b. So now I'm just going to simplify that. So hopefully in your grade 10 review, you've reviewed multiplying these binomials. So you have 3b plus 4 and 3b plus 4 minus 7. So now we have to use our distributive property here. Remember that you need to make sure you multiply everything. I can be a little bit of a stickler about wanting everybody to draw their arrows here to do FOIL. You don't have to, but I find people who draw the arrows make far less mistakes and they don't forget anything. So highly recommended that you do it. There is a shortcut here as well. If you know how to quickly do that, you can as well. So that will give me 9b squared plus 12b plus 12b plus 16 minus 7. And now I'm just going to collect some like terms here. 9b squared plus 24b plus 9. And that would be my final answer. Any questions so far? Sorry about that mistake earlier. Good so far? Okay, awesome. All right, so we're going to do a few more examples, and then there will be a few that I want just to save for you to try on your own, and then come and check the solutions, and I'll post them shortly. So for example 3, we have j at x is 3x plus 10. So we want to find the value of x when j at x equals 28. So sometimes we're not always given the x, we're given the f at x value instead. So this is just like before, if I would have given you a y value and you need to find x. So we have j at x equals 3x plus 10. And we want to find the value of x when j at x is 28. So now, instead of writing j at x, I'm going to write 28. And now I'm just going to simplify to find x. So we want to isolate x. So we start by moving over things that are not touching x. So that 10 has to get moved over. And that will give me that 18 equals 3x. And now to isolate that x, we'll just divide by 3 on this side, divide by 3 on this side, and we will get 6 equals x as our final answer. Okay. So let's try example 4 because the algebra is a little tougher. So for h at x equals x squared plus 20, we need to find the value of x when h at x is 24. So we have h at x equals x squared plus 20. And we know that h of x is 24. So instead of writing h at x, I'm just going to write 24 of x squared plus 20. And now let's try to get x all by itself. So we need to move the 20 over. 24 minus 20 equals x squared. And that will give us 4 equals x squared. But we don't want x squared, we just want x. So we're going to square root both sides, and we will get plus or minus 2 equals x. Remember that plus or minus because 2 squared is 4, and negative 2 squared is also 4. Just don't forget that plus or minus there. There we go. And now for this next one, we're going to do the first two together, and then I'm going to leave the other two for you to try on your own and see how it goes. So for A, we have p at negative 2x. So we're going to be referencing these two functions here. We have c at x is x plus 1, and p at x is 2x. So let's start with A. So p at negative 2x. So instead of writing x in the equation, I'm going to write negative 2x. So we'll have 2 times negative 2x. And now I'm just going to simplify. So that will give me negative 4x. P at negative 2x equals negative 4x. And that is my final answer. So you absolutely can still have x's in your final answer. It happens all the time, especially if I have x's in that bracket. Okay, let's try one more together. So over here, we have c at 3x minus x squared minus 1. And so in my c equation, wherever there was an x, I'm just going to substitute it with 3x minus x squared minus 1. So we'll have 3x minus x squared minus 1 plus 1. And now I can simplify that. 3x minus x squared minus 1 plus 1. I like to originally put it in brackets just in case the numbers impact it and I need to distribute something. It's just a very good habit to get into so you don't accidentally miss anything. So then that will leave us with 3x squared minus, oops, sorry, not an x squared, just 3x minus x, and the other one goes away, and that is it. So what I want to do is I'm going to leave these next two for you here to try on your own. And I'm going to post the answers right after we're done here. But I do want you to try them by yourself just to try to get some practice on them. It's just very beneficial to have a little bit of practice and give it a try. So before we go, are there any last minute questions? No, we're all set? Okay, so there's not much left to do. Just try those two things. And then we will be breaking for lunch. And then we will come back at 12:40. And then there will be attendance taken at 12:40. So they have us doing it 3 times during the day. So just be mindful that we will have attendance after lunch at 12:40. So give those ones a try on your own, and I'll post the solutions right after this. And that's everything. So you're more than welcome to go. You're all set to go and just try those on your own, and email me with any questions you have or if there's any questions at all at the moment. So you're more than welcome to sign off, and then we'll come back again at 12:40.